Hi, welcome to this tutorial on the Poisson distribution. Now this is the second one in the series, and if you want to see all of the tutorials in a larger, clearer format, then what I would suggest is just go onto my website, look under tutorials for the Poisson distribution. Now, as you can see, the aim of this tutorial is to show you how to tackle problems where the interval of time or space changes, and also to introduce the cumulative probability tables for the Poisson distribution. And by using these tables, it will help to simplify a calculation. Okay, well, let's get started then. Now here we have a typical question then, which will demonstrate all these points. In a certain factory, accidents occur at a mean rate of 2 per week. And assuming that the number of accidents per week follows a Poisson distribution, find the probability of less than 3 accidents occurring in a given fortnight. So as you can see, we've got a mean rate of 2 per week, and now we're looking in a given fortnight. So if we assume that the number of accidents remains proportional over a period of time, then we can expect that in a given fortnight there'll be twice as many accidents. So instead of having 2, we've now got 4 accidents expected in a given fortnight. So what I'm going to do is define a random variable, x as being the number of accidents per fortnight, where x follows a Poisson distribution with a mean of 4. So we can expect x to be no accidents, 1 accident, 2 accidents, 3 accidents, 4, 5, 6, 7 and so on. Okay, there's no limit to the number of accidents we could expect in a fortnight. So what we need to do now is just work out then the probability of less than 3 accidents occurring. So we would have the probability that x is less than 3, which would be 0, 1 and 2. So I'm going to say that that's the probability that the number of accidents occurring in a fortnight is less than or equal to 2. And that will be then the probability that x equals 0 plus the probability that x equals 1 plus the probability that x equals 2. Now, to work out these probabilities, we need to call upon the Poisson distribution formula. And we discussed that in the previous tutorial, but I'll bring it up here just as a reminder. And it is that if x follows a Poisson distribution with mean lambda, then the probability that x equals r was given by e to the minus lambda multiplied by lambda to the power r over r factorial. So knowing that lambda is now 4, we can then work out the probability that x equals 0, where r is 0 in this particular calculation. So that would be e to the minus 4 multiplied by 4 to the power 0 over 0 factorial. And similarly, for the probability x equals 1, it would be e to the minus 4 times 4 to the power 1 over 1 factorial. And finally, for the probability x equals 2, it's going to be e to the minus 4 multiplied by 4 to the power 2 over 2 factorial. So all we need to do now is just use our calculators to work this out, and if you do that, you should find you get 0.23810 and so on, which when rounded, say, to 3 decimal places is going to be 0.238 to 3 decimal places. Now, I did say at the beginning of this tutorial that I would introduce you to the cumulative Poisson distribution tables. So I'll show you those now and how we can use them to simplify the solution to this particular problem. Now here we have a typical set of Poisson cumulative distribution tables, and what they do is that given that x follows, say, a Poisson distribution with mean lambda, that's the one parameter lambda, The tables work out the probability that x is less than or equal to any given value x, which you see down this column here. Okay, and the values of lambda that are tabulated in these tables range from 0.5 all the way up through to 5. And there's also another row here that takes lambda from 5.5 all the way up to 10. And I'm sure there'll be other values of lambda further on in the tables. But depending on what tables you have, you're going to find that you get different values of lambda printed across the rows here. But they all work out the probability that x is less than or equal to a particular value of x. So what I'm going to do is take a little section of this set of tables and we'll go back to the problem that we were just dealing with, and I'll show you how we can apply it. So here we have a section of the tables, okay, where we've got lambda at the top here, and we've got the various values of lambda through here and the various values of x down here. Now for this particular problem we've got lambda equals 4, and if we were doing this from the tables we can easily see the answer because we wanted the probability that x is less than or equal to 2. So all we need to do is go to 2 on here where x is equal to 2, go along this row, underneath lambda is 4, and you'll see that you've got this value here 0.2381 printed. So we could have literally said from here, we could have said that the answer was 0.2381, as you see down here, from tables. So tables, very useful. So just be aware of that when you're doing problems. Well, that brings us now to the end of this tutorial, and in my next tutorial what I'm going to show you is how we can extend the use of these tables to work out further types of problems which involve not only using the tables but calculating the mean.